Good morning class 10 and my dear, in the last lecture we have just completed the sulfuric acid. In this way you can simply say that the maximum chapters from the first your class 10 syllabus has completed. Only one chapter is left and that is the organic chemistry. Clear? That's chapter number 8. Clear? So we are just going to discuss about the chapter 8. Organic chemistry. My dear, before we starting this chapter, organic chemistry, I just want to discuss the syllabus of this chapter. Actually, in this chapter, the some points has excluded from this year only by the board, and that's why it is very much required to explain the syllabus of the chapter. Clear? Just see in this chapter, first of all, we are just going to discuss about the introduction to the organic compound. This is simply we are going to discuss about the little bit history parts, vital force theory. Clear? Then we will discuss about the unique nature of a carbon, like it have a catenation properties, tetravalency. It have a tendency to form the multiple bond like a single, double and triple bond. Then we will discuss about the structure of the organic compound, clear, how they are going to represent it, and we will be also discuss about the isomerism. Clear? After completing the isomerism, we will discuss about only the two isomerism, chain isomerism and position isomerism. After that, we will discuss about the homologous series, means the homologous and the functional group. Clear? Then we will start the nomenclature parts, IUPAC nomenclature. In IUPAC nomenclature, basically we will be discuss till the maximum 6 carbon. In that IUPAC nomenclature, we will discuss about the alkane, alkene, alkyne, alcohol, aldehyde and carboxylic acid. Basically, these types of compounds we will be discussed. Okay. After that, we will be discuss about the next one, and that is the hydrocarbon. Alkane, alkene and alkyne. In a alkane, only the normal information of alkane is there. My dear, one more thing is there. In the alkane, we are not going to discuss in this here the preparation of alkane. Only the chemical property of alkane, and in the chemical properties, only the complete combustion of the alkane is there, and the reaction of methane and ethane with the chlorine through the substitution reaction is only the combustion, and combustion is there and that substitution is there. In alkene nothing is there, and in alkyne only the normal information is there. So in both, means in alkene only the normal information, in alkyne normal information. No chemical properties, no physical properties, no usage and no preparation is there. Okay, so simple chapter is there, and the chapter is not a very big, because the last year it was concluding a lot of points, but this year very less number of points are there. So just we are going to discuss about chapter number 8, organic chemistry. Start the points. So the first point, organic chemistry. What organic chemistry say? First, it's the historical part. It's the history we are going to discuss, and that is history. History is not a lot of in our syllabus, but just for the information, because it is required in the class 11th again. So I am just going to inform you the father of the modern chemistry, named as Antonio Lavoisier. Who was considered the father of modern chemistry? Antonio Lavoisier. Antonio Lavoisier, who was considered the father of the modern chemistry, has classified the chemistry into the two parts, and he has said the name of the first part is he has classified the chemistry into two parts. First, he has said all the compounds which are obtained from the living organism, all the compounds which are obtained from the living organism are called the organic compounds, and the related chemistry is called the organic chemistry. While all other compounds which will be obtained from the earth crust and the atmosphere are called inorganic compounds, and the related chemistry is called inorganic chemistry. It is called inorganic chemistry. So these are the two different points. Clear? Once again, according to Antonio Lavoisier, all the compounds which are obtained from the living organism which are obtained from the living organism, is like a plants, like human beings, plants and animal kingdom. They are called organic compounds, while all the other compounds which are obtained from the earth crust, atmosphere, or from the other sources of the nature, they are called inorganic compound. Clear? And the related chemistry is called inorganic chemistry. This classification of our chemistry into two parts is basically based on the Berzelius vital force theory. One chemist was there, his name was Berzelius. He has given a vital force theory. So this classification is depends upon the Berzelius vital force theory. Vital force theory. And what is this vital force theory? According to this theory, organic compound can only synthesize in the living organism due to presence of a very important or a special force inside their body. Clear? Just now we are knowing that is pran or jan. They are living beings. So only the living beings can synthesize the organic compound because they having a special power. Clear? And that special power is called the vital force. Clear? And due to presence of this vital force inside the body of human beings or the living organism can synthesize the organic compound into their body. Organic compound cannot synthesize by the non-living substances or in the laboratory. Means the organic compound cannot synthesize in the laboratory because that a vital force is not present in the laboratory. Vital force is only present inside the body of a living organism like human beings, plants and animals only. Clear? So organic compound can only synthesize by the living organism according to the Berzelius, and this is the vital force theory. Clear? And that was successful nearly the 100 years. No any objection has come, but the first objection has come in 1828. In 1821, one chemist was there. His name was Olaf Bohler. And Bohler was the first chemist who has synthesized the organic compound urea from inorganic compound ammonium cyanide into the laboratory. Yes, the first organic compound which has synthesized into the laboratory was urea. It's formed as the NH2CO. So the vital force theory which was given by the Berzelius is what it has a rule over the 100 years or nearly the 100 years. And after that in 1828 one chemist has come. His name was Bohler. He has synthesized the first organic compound urea into the laboratory, and he has opposed the vital force theory. He has said the organic compound can be synthesized into the laboratory. No any vital force is required for preparation of an organic compound. Clear? How he has prepared? He has taken the ammonium cyanide NH4CnO. Its name is ammonium cyanide. And it is an inorganic compound. And after heating, only he has got the organic compound urea, NH2CO. Its name is urea, and it is an organic compound. Getting? But the problem was there, that is the chemical reaction, and in this way urea has prepared from the ammonium cyanide into the laboratory. But the follower of the Berzelius, clear, they have said the chemistry is the home of the exception. One or two organic compound can be synthesized, clear. But if some more will be prepared into the laboratory, then only we will believe if there is no existence of a vital force theory. And my dear, after the 1828, nearly the 10 years, no any organic compound has prepared. The next organic compound has prepared in the year 1842 by the Berthelot, and then in 1845 by the Colbe. Then in 1842, Berthelot has prepared the second organic compound methane, and Kolbe has prepared the third organic compound, acetic acid, into the laboratory. Clear? And then this thought has come in the mind of the chemist that organic compound can be synthesized into the laboratory. It is not required of special force. No any vital force is required to prepare the organic compound. And after preparation of these three compounds in the year, clear, the chemist has motivated to prepare some more organic compound, and then after that the chemist has prepared a lot of organic compound only in the laboratory, and finally the vital force theory has vanished. So you have got what is the vital force theory? According to this theory, organic compound can only synthesize into the inside the human bodies or animals or a plant kingdom due to presence of a special force, and that is called the vital force. Organic compound cannot synthesize into a laboratory. But in 1828, F. Bohler has synthesized the first organic compound, urea, into the laboratory, and followed by some other chemist has prepared the organic compound. Clear? Who has been prepared? In 1842, Wakelot has prepared methane, and Kolbe has prepared the acetic acid into the laboratory, and both are initially named as the organic compound. So two organic compounds has synthesized into the laboratory, three, and then the vital force theory has vanished. And after the vanish of the vital force theory, a new concept of a chemistry is required, and that is called the modern concept. According to the modern concept of the chemistry, organic compound are that compound which contain the carbon or its derivatives. Once again, all the compounds which contain the carbon or its derivatives are called the organic compound, and the related chemistry is called organic chemistry. Means every compound in the nature which is containing the carbon are called the organic compound. Clear? Except carbon dioxide, carbon monoxide, metal carbonates, metal bicarbonates, metal cyanide, metal isocyanide, metal cyanide, metal carbide. Clear? They are containing the carbon, but they are not considered as the organic compound. Clear? And the proper reason is not behind that thing. Generally, we are saying because these compounds are not containing the CH bond, carbon and hydrogen bond in it, and that's why they are not considered the organic compound. Clear? So they are the organic containing carbon, but they are not considered the organic compound. Rest all elements of the nature, rest all compounds of the nature having a carbon, they are called the organic compound. Clear? Except these. Okay. So this is the new concept. My question is there, my dear, all the compounds of carbon, all the compounds of element carbon are called the organic compound, and the rest all the compounds of 119 elements, 117 elements. अब 118 है, एक कार्बन हो गया. So rest 117 elements are there. So the compound of rest 117 elements is called inorganic compound, and the compounds of carbon only is called organic compound. So my question is there, which compound will be larger, inorganic compound or organic compound? So your answer will be big yes for the inorganic compound. You will be say, sir, because 117 elements are there in the inorganic compound, so they will form the larger number of compound, but it is not true. Clear? The total 117 elements of the periodic table, they are forming the inorganic compound nearly about the 5 crore. But carbon alone form organic compound more than the 50 crore. Means nearly the greater than 10 times organic compounds are there in the inorganic compound. Just think. It may say carbon having some unique properties, carbon having some unique tendency. That's why it will form the large number of organic compounds. Clear? So here we are going to discuss about the properties of carbon or unique tendency of carbon. Clear? Better unique tendency of carbon. or unique nature. Unique nature of carbon. What are the unique nature of carbon? The first unique nature we are just going to discuss, and that is the tetravalence. Tetravalence. What is the tetravalence saying? It is saying carbon having the valency 4. It having a valency 4, and that's why the carbon can join with the 4 other atoms or elements in a 4 different directions. It means all in 4 possible directions, carbon can join with the 4 other atoms. Clear? And its valency is 4. First. Second is the catenation. What is the catenation? The tendency of an element to self-linking and forming a long chain is called catenation. Once again, the tendency of any element, the tendency of an element to self-linking and form a long chain is called catenation. And this catenation property is highest in the carbon. Carbon having highest tendency of self-linking. Self-linking means catenation. No any other elements of the nature can form the more longer chain than the carbon. Carbon will form the longest chain. Clear? So that is the catenation. Okay. Now the third point and the third is the multiple bond formation or multiple bonding. Multiple bonding. What is the multiple bonding? Carbon can form single, double or triple covalent bond or triple covalent bond. It means the carbon between the two carbon atoms, so single as well as double or triple, all the 3 types of a different bond can be formed, and this tendency is not in any other elements. No any other elements of the periodic table can form the all 3 types of a multiple bond, means the single, double or triple. Like a carbon, oxygen. Oxygen can form only the single or double. It cannot form the triple. Hydrogen, only single, no double. Nitrogen, only single and a triple, no double. Clear? You can take any elements like a chlorine, only single. Sulfur, only single or double. No triple bond is there. Carbon can form the single, double as well as a triple covalent bond, and that is its another unique properties. Clear? The next unique property of a carbon is the isomerism. Carbon having also unique property of isomerism that we will discuss in the next day. What is the isomerism in the next lecture? Clear? So that I am going to record the lecture today only, but I will be sent on in the next day. Okay? So have a good day. Bye bye class.